Hello friends, in this video we are going to discuss about one of the important classification of analog pulse modulation technique, that is pulse amplitude modulation. This is the first classification of analog pulse modulation technique. Here the amplitude of the carrier pulse is varying in according to with the amplitude of the message signal. Here observe the figure shows the block schematic of PAM generator. Here we have a figure. This block diagram shows the block diagram which is used to produce the PAM modulation. Okay, now let's see. It consists of low pass filter, a multiplier and a pulse generator. The block diagram of pulse amplitude modulation consists of low pass filter, multiplier and pulse generator. Initially, the modulating signal x of t is passed through the low pass filter. Initially, the modulating signal is nothing but message signal is passed through the low pass filter for eliminating the noise or any error. Okay, the low pass filter removes all the frequency components which are higher than the frequency f. Okay, in message signal, or if I want to perform the pulse amplitude modulation, I will provide the message signal. This message signal amplitude is f. Okay, that's why I put low pass filter before the modulation to remove all the frequency components above the f, and it permits only the low frequency components which are lower than the this f. This is known as band limiting. Here we are limiting the band of frequencies. Next, the band limiting is necessary to avoid aliasing effect in a sampling process. Here this band limiting is nothing but low pass filter. This low pass filter allows only frequency components which are lesser than this f. Okay, which are only lesser than this f, that frequency only allowable by low pass filter, that is nothing but band limiting. This band limiting is useful for avoid the aliasing effect. This band limiting is useful for avoiding aliasing effect. Now let's see the pulse train generator. Here the pulse train generator generate a pulse train at a frequency such f is greater than or equal to 2 fm, thus Nyquist criteria satisfied. Here observe, here this f first f is nothing but fs and is greater than or equal to 2 fm. This situation is nothing but sampling theorem, or if suppose fs equal to 2 fm, then that is known as Nyquist criteria. Okay, if fs equal to 2 fm, then that is Nyquist criteria. If fs is greater than 2 fm, then that is known as normal sampling theorem. Okay, the pulse sampling network does the shaping work to give flat tops. Here we are generating the pulse amplitude modulation. If we perform the pulse amplitude modulation, first we will get the pulse amplitude modulated wave without flat tops. After it is applied as the input of shaping work or pulse shaping network, then we will get flat topped pulse amplitude modulation. Now let's see block diagram of pulse amplitude modulation. Here observe, this is the block diagram of pulse amplitude modulation. Here first block is low pass filter, second block is multiplier, and third block is pulse train generator, fourth one is pulse sampling network. Here our modulating signal or message signal is sinusoidal signal is applied to the low pass filter. This low pass filter eliminates all the higher frequencies, okay, and pass only lower frequencies, and this low frequency message signal is applied to the one of the input of the multiplier, and another input of the multiplier is pulse train generator. This pulse train generator generates the train of pulses like this. This pulse train generator generates the train of pulses like this. Here if we multiply the input message signal and pulse train, then we will get PAM modulated wave. This is the PAM modulated wave. In order to get the flat tops, for the PAM modulated wave, we are using pulse sampling network. This pulse sampling network is used to give the flat tops. Then we will get the PAM signal. Okay, that pulse sampling network is used to give the flat tops. Here, observe these waveforms. The first waveform is the modulating signal or message signal, and second waveform is the pulse train generator output. This is the message signal. This is the this is like carrier signal, and the last one is PAM modulated wave. Here, output or PAM modulated wave. Observe this PAM modulated wave. Here, the amplitude is varying in according to the amplitude of the message signal. Okay, this is about PAM modulation. I hope you understood this. Thank you for watching this video.